Okay guys, in this video we are going to take a look at a method of elimination, but this is going to be special case. So what does that mean, special case? Well, you'll see in a second. So at the first glance, when you just look at the system of equation, it doesn't look like there's anything special about it. So we'll just proceed as though nothing special is going on. We want to, let's say, eliminate x. Now in the first equation we've got the coefficient of x missing, but what that means is that the coefficient is just 1. We usually just don't write 1x. We just write x, but you need to understand that that means that the coefficient is 1, and the other one is -3, right? So we got 1 over here and we got -3 over here. Now what we want is we want these two numbers to be opposites of each other, so that when we add the x terms together we'll get 0 and x term will cancel. So what we'll want is one of them to be, let's say, -3 and the other one is 3. Well, one of them is already -3, so all we have to do is multiply the first equation by 3. If we do that, then x will eliminate once we start adding the equations. So also remember that when you multiply by a number, you have to multiply each term by that number, not just the first term. So this is going to be 3 times 1, which is 3x, then minus 3 times 10 is 30, y equals 3 times 2, that's 6. Okay, now the second equation we're just going to leave alone, so we'll just rewrite it. And look what will happen in a second. So now we're going to start adding them up. Well, 3x and -3x, that's just going to cancel, and that gives you 0. Then -3y plus -30y plus +30y, well, that's also going to cancel. So imagine that. So this is also going to be 0. And then equal to, guess what? And 6 minus 6 is also 0. So what we get is, well, 0 plus 0 is 0. And so we get something weird, right? That's why we say special case. So 0 equals 0. What does that mean? Well, the thing is 0 is equal to 0, okay? It's like, well, thank you very much for that. Like, I am me or something like that. Yes, 0 is 0. So basically what that means is that this is not giving you any solution. You are not able to solve it either for x or for y, because everything cancels out. So what that usually means is that even though it looked like the two equations were different at first, but it turns out that they actually represent exactly the same line. So if you try to solve both of these equations for y, you will wind up with the exact same thing. So I'm not going to check that, but you can check that if you solve it for y, you get exact same equation. So basically what that means is that, imagine that you draw the first equation, or the second, doesn't matter. So this is like x minus 10y equals to 2, right? So what it does is, for example, when y equals 0, x equals 2. So let's say this is 2, so it'll go through this point. And when x equals 0, y will be -1/5. So I don't know. So it could be something like over here somewhere. So there is your line, right? Let me try to draw it. So this line is just going to be something like that. And then the second one is going to be exactly the same thing. So it can be shown that the line itself is like coincides with the previous line, right? So what that means is that every point on this line is going to be a solution. So for example, a possible pair of solutions will be something like, well, when y equals 0, you get x equals 2. So 2, 0. That's a solution of this system. Also, for example, when x equals 0, y would be -1/5. So that's a solution. But that's not the only possibility. For example, if x equals 10, let's say, or 12, let's just say it's 12. Okay, so what would that mean? So 12 minus 10y equals 2. So let's subtract 12 from both sides. Gonna cancel. So you'll just get -10y equals 2 minus 12, that's -10. So that just basically means that y equals 1, right? So it's also possible that 12, 1 is a solution. So it turns out that every time we select a certain value for one of the variables, we can solve for the other one. So we have every single point on that line is a solution. So that tells you that there is infinitely many solutions. So when you get to a situation with a 2-by-2 system, so 2 equations, 2 variables, where you get 0 equals 0, that tells you that there's just infinitely many solutions.